Welcome, everybody in the lecture hall. Welcome, everybody on Zoom. Welcome, everybody from the future. Today, we will spend most of the time continuing with SQL and learning all the secrets of how you can query data, a lot of data with just a few lines of code in your Jupyter notebook, and the results magically appear on your screen. Before we do that, I have a few questions to ask you to just test your knowledge and check that we're all up to date. So let me just go to this one, for example. Which query produces this output? So this is, you can see a table on the top called my table. And then the output is below the arrow. So AED bar to bar, this is the output that I would like. And I am giving to you these queries, these 4 queries. And I would like to know which one of these is giving me the table that is above. Let's look at your answers. We have a majority vote. And the majority vote is the second one. You can still change your answer if you want, still have a chance. Do you see why the first one doesn't work? All right, let me just close. So it is the second one. Oh, yes, you changed. All right. So this is indeed the second one. It cannot be the first one because the second column is called E. So if you just say select ABD, you wouldn't rename it, and then you would not get this result, but you would get the column B with still the same name. So it cannot be the first one. The second one is fine. B is smaller than C and A equals D. So that would be these two, and then bar and bar. So this is the one here. And then B greater than C is unknown. That would be this one here. So that's not what we expect. And then B greater than C, that doesn't exist. It's not the case anywhere. So this is why not the last one. All right, but you got 100% on this. Perfect. Not that yet. Now, this is a schema, but in SQL, create table, right? You're familiar with these statements. And I'm asking among these tuples, which one or which ones satisfy the constraints of the schema. So the notation for the tuples is not standard, right? I'm using this ASCII art with the equals greater than for the functional arrow. This is totally arbitrary, but you understand what I mean, right? So for example, the first one says that it's a tuple that maps A to ABCD, that maps B to 1, 3, 2, 4, C to this date, and D to true, right? So this is the notation that I use, right? But these are all tuples. And so I'm asking the ones that would be compatible with that schema. Did I start it? Yeah. Manage to display everything on the same screen. I think there's only one that works. I think we have enough votes. Let's see what you say. Aha. So let's see. It was the last one. So let's see why. So the first one, do you see why it cannot be it? Anybody? Why can it not be the first one? Exactly, it has 4 characters, but we say char3, so it can be only 3. So that's not the first one. Why can the second one not be the correct one? Yes? E doesn't exist, so that doesn't have the supports that the schema requires. Why can it not be the third one? Exactly. Numeric takes 2 parameters. The second one is optional. The first parameter is the precision. It's the total number of digits. If you ignore the decimal period, the total number of digits. And the second is where you put the decimal period. So the number of digits after the decimal period. Now, if you don't say anything, if you don't say what the second parameter of numeric is, then there's no decimal period at all, or it's at the end. So basically, numeric 5 has only integers that are smaller than 100,000, 5 digits, right? So you cannot have anything after the decimal period, right? So this is why it cannot be the third one. And now if we look at the last one, the last one is fine. I have A that maps to ABC, so that fits char3. B doesn't have any decimals after the period, and it only has 4 digits, so that's fine. That's 5 digits of precision. B is null. That's fine, because you know that by default, if you don't say anything, then null is allowed, right? You would have to say not null to disallow for null. But since we don't say anything, then null is fine. And C is a date, 2017, 10, 12. I didn't put any trap in there, right? It's clear it's a date, what it's meant as a date. Do you see that D and C are swapped? But we couldn't care less because that's a function. So when there's a function or a map, you just map things. It doesn't matter in what order, right? So this is why we don't care about the order in which we specify the mapping. It will just be in the right columns once you put it. All right, so that takes care of this question. And now I have 4 expressions here that would, for example, go to the where clause in a SQL query. I'm asking for the ones that do not return unknown. So some of them are return unknown and some of them do not return unknown. Knowing that we are evaluating these expressions on a specific tuple, and that tuple is price 23, and the name is null for that tuple, right? So we have 23 and null in the columns price and name. So which ones do not return unknown? So which are the ones that you can successfully evaluate to true or false? You remember SQL has 3 valued logic. It means that when you evaluate predicates, it can be true, it can be false, or unknown. And so okay, we are at 8. So let me look at your answers. What do we have? Wow, 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 wow. Okay, so it's divided. Okay, so let me reveal the solutions first. So the second one and the last name. Okay, so let's do them one by one. The easiest one is the last one. We ask if name foo is unknown. Well, for sure, I told you if you use is unknown, is null, is not null, and so on, these ones never ever evaluate to unknown. If you use this, it's guaranteed it tells you yes or no, it's true or false. So if you say name foo is unknown, we can even try to evaluate it. So name equals foo, well, name is null, so we don't know. So if you say name foo, which we don't know, is unknown, then it's true that it is unknown, right? So this is why it's actually true. But even without evaluating it, you see is unknown, you know anyway this is true or false. These ones. Okay, so that was the easy one. Not name equals foo. Why is it unknown? Exactly. Name is null, so name equals foo. We don't know if it's foo or not because it's null. So there's nothing in there, so we don't know. And if we don't know if name equals to foo, then we also don't know if it's not the case that name is equal to foo, right? So if we don't know if it's true, we also don't know if it's false. So not name is equals foo is unknown. Then price smaller than 22 and name equals foo. Why do we know the value? What is the value of that? Yes? Yeah, exactly. So price lower than 22 is false and something else, but it doesn't matter what there's after the end, right? You're asking for a lot of things to happen and you already know the first thing doesn't. So you don't even need to look at the rest. You already know it's false. So this is why we don't even care if name is foo or not. It's anyway not true that price is less than 22. So this is why this one is actually false. We know it's false. And the first one is because you see the difference, there is an or in there. So we're asking if either price is lower than 22 or name equals foo. The problem is that we know already that the price is no longer than, it's not lower than 22 because it's 23. We would like at least one of these to be true. Well, the first one, that's already lost, right? That one we lost. So price lower than 22, we can throw it away. That's not going to happen. So the only one that's left is name equals foo, but that we don't know. So price lower than 22 or name equals foo is also unknown. Okay. So this is it. So that's the logic. It's really common sense, right? There's no heavy math in there. It's basically just asking the question, do we know? Do we have enough information to know? Okay, so that's three-valued logic. It's not easy at all, right? That's already advanced math to, there's full formalism for this three-valued logic. There are even people who, I think, deal with fuzzy logic, meaning that it's not even just a true, false, unknown, it's even a degree of probability that it's true and so on. But of course, this is way beyond SQL and relational databases. All right, so now that I know you're following, I'm getting back to the slides. And we're taking it from where we were last time, which was here. This is where we left. We saw this select from where order by limit of set. So just to recap a little bit, what I told you is that first you need to learn that by heart, this select from where order by limit of set. What's really nice, because that's the early versions of databases, is that it's always in that order. You cannot do any other order. You cannot say, for example, select from limit order by where offset. That you cannot do. It has to be select from where order by limit offset in that order. So you can learn that by heart. They're optional. You could omit where, you could omit order by, you could omit limits or offset. You do need select and from though. I mean, these are the two that you really need, but the others are optional. And I gave you a little word of warning. I told you be careful. If you use limit and offset alone without order by, be prepared for a bit of randomness. And it's not even deterministic. Because if you don't specify any ordering criterion, then the database basically just does whatever it wants to do. That's what I told you. So you can still use limit on its own. It's useful for one purpose, not overloading your Jupyter notebook. So that you can still say, for example, select from and then limit 10, that's fine. Just be aware that it's just returning whatever 10 tuples it wants to. You have no guarantee on which ones it's going to be. Who is with me? All right, who knows them by heart? Select from where, order by, limit offset? Who doesn't know them by heart? Okay, let's do it together. Everybody, select from, no, everybody, come on. Let's go. Select from where, order by, limit, offset. Exactly in that order. And now we will introduce others. Oh, what's going on with the screen? Let me give me 1 second. I might be able to fix that if it's just a matter of where I put the HDMI thing. So let me see. Maybe if I plug it somewhere else, it's going to fix it because it's not very pleasant otherwise. Let's see if that's better. You probably don't see any difference on Zoom, but in the lecture hall, the display is kind of weird. That took care of it. Okay, so now you have a proper display. Would not have been nice to go for 2 hours like that. All right, so now I'm just going to introduce other clauses. There's more than that, and we just look at them. So what we will look at now is aggregation. Aggregation is probably one of the most powerful and useful features that you can have in analyzing data. In fact, if you're the Federal Office of Statistics, you do that all the time, or the Cantonal Office for Statistics. This is basically what offices for statistics spend their time doing. It's aggregation. High-level views of the entire population of the country, putting people in categories, computing averages, counts, and so on by category. So how does it look like? Well, you remember that we did the math already. That's this gamma. You remember the Greek letters, sigma for selection, pi for projection, and so on. Well, for aggregation, we use gamma. And in the gamma, I told you that we have 2 kinds of things in there. We have the grouping keys that are on their own. So this determines the group we do, country and city. So it means we group everything by country and city. That's the first category. And the other category is what you aggregate. So here we have this notation where within a group, determined by this, within a group, you sum over the prices and put that in a column called volume, and you count the customer in every group, and then put that in a new column called num transactions. And then you get this, right? So again, country and city, these are the 2 that are on their own, grouping keys. And then the 2 aggregated columns are here. This was a sum of these, and this was a count of these. Okay, so that you remember from 2 weeks ago. How do we do it in SQL? Well, it's even easier than this gamma Greek letter stuff because we just say group by. So this is a new clause that we can use. So here we group by century. So it means century is my grouping key. That would be the one that is on its own. And then what do I aggregate? Well, I just count. So basically, I group all of the tuples by century, not country, century. And I count how many there are per century. Now, if you look at the table, you can do it in your head, right? There's 2 that are in the 23rd century and 2 that are in the 24th century, right? You see the first and third tuple are in century 23. The second and fourth tuple are in century 24. So what I get is 2 groups, 1 group with century 23 with a count of 2, and 1 group with century 24 with a count of 2. Who is with me? That should be easy, right? Now, what happened here? I didn't specify a name for the column for the counts, right? This is okay. You should, of course, it's a better idea to do that. But if you don't, PostgreSQL is doing it for you. So if you just say count, then PostgreSQL is just calling the column count like this. All right, but if you want to specify, of course, manually, and you can call it whatever you want, then you can specify the counts. So what is very important here, and you have to be careful because SQL is powerful and you could get things wrong if you write a query that doesn't make sense. So what is very important that you consider when you use a group by, that's a golden rule that you absolutely must follow. It is that this grouping key, you really must write it twice. You really must write it once in the group by clause and once in the select clause. Always, always put them in both places. If you don't, for example, if you say group by century, but you don't put it in there, you won't receive any warning or constraints. It just will not be displayed in here. The problem is that that doesn't make any sense, right? Anybody looking at this is not going to understand what's going on here. If you just look at the counts, what is that, right? So it's a really bad idea to not be consistent with the 2. So take it as a golden rule. Whenever you write something in group by, all the columns you put in group by also have the habit of putting them first in select. And then you can aggregate all the rest, okay? Golden rule, stick to it. That's called a grouping column or a grouping key, depending. So in that case, we have only one grouping key, but you can have several. And so by definition, of course, the other columns are not grouping columns, right? So you have the grouping columns and the non-grouping columns. That's only based on your query. If I give you another query, of course, that's going to be different grouping columns. And so the idea is that you can aggregate on the non-grouping columns like this, okay? Now, what are the things you can get wrong? So one thing you could get wrong is that you try to add to the select clause a column that is not a grouping column, like H here, but without specifying any aggregation. That doesn't make any sense, right? So you really cannot add a column just like that is not a grouping key. I mean, what would you put in there? Imagine that it's the group for century 23, H could be 57 or 189. There's two values. So you have to aggregate it in somewhere, right? You cannot just have it on its own. So that doesn't make any sense. Do not do it. You might even get an error from PostgreSQL if you try to do that. So you really, really have to specify an aggregation function, right? Like count H is going to count the number of H values. Do you have any question? Normally there's a question here, but it's not. Yes.
I want to select a first name group by group by middle name. You have two nulls. So because group by you have to compare the different string or integer or whatever. Since it's null and null equal null is again unknown, how does it go?
That is a very good question. So this is already advanced. So we'll check it in the documentation, but basically the behavior of the nulls is always a bit special and a bit fishy. It's like vector spaces of dimension 0 and so on. So there's two ways to look at null. So there's null, but there's also the none, right? Not a number for doubles, which behaves a bit similarly. And so what happens is that at some places, you consider that all the nulls or all the nons, they're all equal to each other and belong to the same group. And in some other cases, you consider that they're all distinct from each other, right? So there's really a different, depending on where you look. I think, and we will check in the documentation, I think that when you're trying to group by, it considers the nulls to all be together. I think it all puts them in the same bucket, right? But again, be careful because that's not always the case. There are other places where you consider that all the nulls are distinct from each other. Okay, we will check and get back to you to be absolutely sure that I'm giving you a correct answer. But I think if you say group by middle initial, it would have three groups, very likely, right? And then if you count, for example, you would have one T, two Cs, and two nulls. One T, one C, and two nulls. Okay, does it answer your question? All right. Is there a question? There should be a question now that people always ask. Okay, let me show. Look at that slide and look at this other slide. Does really nobody has a question? Nobody has a question. Okay, so the question is usually like, what's the difference between this count H that specifies a specific column to aggregate, which is what I told you for the relational algebra, and this count star, because count star is not a column. There's no column called star, right? So what's the difference between the two? Well, the difference between the two is that count star is just counting the number of tuples that there are in your group, right? Doesn't even look at the tuples, just counts them. So this is why you don't specify any column in there when you count, just the number of tuples. But if you say count H, it's going to specifically count the number of values that are not null in that column H. This is what it does. So that's the difference between count star and count of a specific column. So if you say count H here, it will be 2 and 2, but it's not going to count the nulls. So here there are no nulls, so it's the same result as count star. But if there had been a null in there, that wouldn't be included in the count for the column H, of course. Who is with me? Yeah. Typically, people use count star. If you don't want to know the number of people, so I think that this query is much more popular than here. Here, it's really somebody who really has the nulls in mind and wants to exclude the null, who writes something like this. Okay. All right. So here, yes, we give another name to the column. So with as, so you can see that you can put this as a, we learned that right last week with the renames, how to rename a column. And you can, of course, use the as after a count aggregation, of course, to give it another name. Okay. Note that there's something I didn't say that happens, is that, you know, the types of your columns, the domains of the columns, these are the ones you put in create table, right? But this column here was not defined in a create table statement. It's a column that was created on the fly to count. And what happens is that PostgreSQL will automatically make it a big int. Remember the big int? I think it's this 64-bit, the largest integer you can possibly have with a fixed number of bits. So this automatically, if you do a count, it's automatically creating a big int domain in here, right? At least it will not have a problem with Gangnam Style when it hits the 4 billion limits. Okay. All right. And here too, no, that was something that doesn't work. And here too, it's a big int. You see, you create a count as a, that's a new column. So in particular, you see that even though it was built from the column H, the type changed. It was an integer, and now it's a big int. And again, the big int is because you're counting. That's the reason. It can be anything in there, could be a char3, could be a date or anything. The moment you count, you get a big int. All right. And here you get a big int as well, of course. And that was my example for the nulls. That if you say count middle initial, there's two groups, but these nulls here, you count here, these are excluded from the count because of the count of a column. So you take them away and you just have one tuple that has a middle initial not null for 23 and one for 24, and these two are ignored. So this is why in that case, it would be different from the count star. Okay, you see, so that's the difference between the two. Okay, now the example that I gave you was specifically with a count. But there's others than count, and that I also explained to you last time. Do you remember the top 5 aggregation operators? I told you, you must know them by heart, the top 5. What are they? Yes? You said min twice. Oh, yes, yes, absolutely. So indeed, sum, count, min, max, and mean average, AVG. Yeah, absolutely. These are the top 5. These you should know by heart. These are really the most common ones that you would aggregate over. There are others, of course, there's many other things you can do, like the standard deviation, you could do concatenation. I mean, there's many, many things you can do to aggregate values, but these are really the most common ones, the big 5. There's also bool or, that basically is an aggregation of booleans. Bool end also exists. String ag would aggregate strings by concatenating them. I mean, these are more advanced, but the top 5 is really max, min, sum, avg, count. Okay. So now, if you want a minimum, just write min in here. So here is going to take the minimum h that it can find, right? So that's 57 less than 189 for Spock and 35 less than 41. So that's the min. That's the max. Now we have 189 for Spock in the 21st century and 41 for 24. Then we have sum. So this is 57 plus 189, 35 plus 41. Then we have the average of 57 and 189 gives you 123. And the average for the other group between 35 and 41 gives you 38. Okay? Yes? So in that case, let me go back to the type of the column, and that should answer your question. If I compute the minimum, do you agree the domain of the output is the same? If you do the minimum of values, it has the same type. So min and max, that's the same domain. The sum, we assume it's a summable column. That's something you can sum, but it's also the same. If you sum 2 integers, you get an integer. Now, did you see what happens with the domain here? It changed the type. It's no longer, if you do the average of integers, it's not going to spit an integer. It's going to spit a numeric value with digits after the decimal. In that case, turns out that there were none, but in general, it could output a decimal number with digits. Does it answer your question? Yeah, all right. This is all in the PostgreSQL documentation, by the way. There is a page dedicated to grouping and aggregating, and it tells you exactly for what aggregation and what types, what you get in the output domain. All right. So it's just like the count that creates a big int. If you have an average on integers, it's going to change the type, to change the domain of the column to numeric, right? Okay. Numeric, if you remember, is an arbitrary decimal number with any number of digits. Okay. Here's Booleans, bool_end. So bool_end might also be known as a universal quantification. Whoever heard of that, universal quantification? Who already saw an A letter, uppercase, but upside down? That you saw, right? That is called the universal quantification. So in that case, bool_end basically is returning true if all the tuples have this value true. That is, for all tuples, the value of the column captain is true. This is what bool_end is doing. So here you can see that if you look at 23rd, we have true and false. So it fails because one of them is false. And for 24, you have false and true. So it's also false because one of them is false. It would only be true, the bool_end, if everything is true. Then you would have a true. Okay. Then you have bool_or. Bool_or, do you know the symbol for that? Existential quantifier. Letter E mirrored left, right. Right? The E that is mirrored. So that is an existential quantifier in mathematical formulas. So this is the for all, and this is the exist. The E is for exists. Okay, so then it's true because there's always one of the two that is true in both groups. Okay, and here is a string ag, just for the purpose of showing you. So now I still have my two groups, but now what it's doing, it's aggregating all of the values. So let's look closer. First name here. So we are aggregating 23, 10, 23. So we are aggregating James and Spock. And 24, we are aggregating Beverly and Catherine. Now, the second parameter here is a separator. It means that in between, there might be a lot of values. In between each two values, it's going to add a comma and a space. So this is why you have the comma and the space here. And if there's more, it's going to be a comma and a space every time, right? It's very convenient because I don't know if you've ever coded in other languages like Java or C and so on. I mean, now there's libraries, but trying to concatenate string with adding a separator in between is tricky because you have to remember to not add it the last time. So it's actually not so straightforward to implement. But for convenience, when you have a functional language, it's much easier. You just specify the separator and that's it, and PostgreSQL deals with the rest to only add it in between. Okay, so these are the advanced ones. They're not so common, these ones. Most of the time, you're really going to use count, sum, max, min, and average. Okay. Okay, so let's continue. Now we have compound grouping keys. What does it mean? It's when you have multiple columns that you group on. So in that case, we have two grouping keys. It means that we create groups that have the same century and captain. The first thing, and I already said that, but I repeat it, that's my golden rule that I gave to you. The moment you write these two columns here to group by, you should have this automatic thought of also putting them in select. Do not use only one of them. That doesn't make any sense in the output. You wouldn't get a warning, but the output will be very confusing. So always remember, you put them at these two places. And then we have the count. So how many distinct ones? Well, we have 23 true that has one that came from this one. Then we have 24 false, that is this one. And then we have 24 true. These are the two here, the two tuples, right? Remember that this counts the number of tuples. Okay, who is with me? Okay. This is what I'm telling you not to do. This is a counterexample of what you should not do. And that should be clear. Look at the results. What can you make of this output, right? You see 24, 1, 24, 2. Nobody can use that. This is basically garbage output. So this is the reason you really should include all of the grouping keys in the select clause, like here, and do not do something like that. Okay. All right. Group by. Now there's another clause that I would like to introduce to you, which is called having. Having, in fact, is not really new. It's just a where clause, but it's a where clause that comes after the group by. It means that it's basically a sigma. Having is a sigma, just like the where clause in terms of it's a selection. But again, unlike where would be before the group by, having would be after the group by. And because having is after the group by, having sees the count. Where would not see the count because that's before the group by. But after the group by, you have already counted. So now you can say group by century, but only the groups that have a count strictly greater than 2. What that does is that it will only output. So if you select the centuries here grouped by century, you don't care about aggregating anything. You're basically selecting the centuries that have at least 3 counts. So you only have 24. I modified the data, by the way. There's now 3 24s in there to make my point and 1 23. So 23 here disappears into oblivion because of the having clause that would filter it out. Okay. Who sees that it's basically the same as a where clause just after the group by? Okay, awesome. They could have called it where, by the way, but I think they just thought it's easier if it has a different name to not confuse them. Okay, now you see the Greek letters become more complicated, right? Because now if you have a query like that, the from gets the table, then the where applies the sigma before grouping, then you group with gamma, then you select again, but with having, because it's after the group by, and then you project with the select clause. That's the part that I told you is weird. You project with the select clause, but this is what is happening, right? Pi. All right, so you see the gamma really cuts it in the middle. There is the pre-grouping, what happens before we do the grouping, and what happens after we do the grouping. And then you can build, so this is the flow, and then you can build trees like this. This would be a query plan that you would get with 2 sigmas, one before the gamma and one after the gamma. Okay, so I repeat what I told you, the best practice. Which one did I told you? Yes, the second one. Always include all grouping columns in the projected output that I told you. Put them all in select. The first one, always rename aggregated columns. Always give them a name. You could not give a name, but then PostgreSQL will invent something. It will come up with any name that it wants. But it's always better that you say the name because at least it's predictable. You know exactly what there is going to be. Now, unless, so this is basically an example where that's not true, but usually when you group, you tend to also aggregate. So it's rare that you would have a group by without any aggregation. There's 2 exceptions. One is you just want to create the group for the purpose of finding distinct values, but then you can just use select distinct. So instead of saying, for example, select century from people group by century, and you just want to have the distinct centuries, instead of doing that, you would say select distinct century from people. It's easier, but it does the same thing. The other exception is if you want to filter, then of course it's useful to have this because the having, you could only have having on account. You need the group by for that. If you use the select distinct, then you couldn't do that because you couldn't use the having clause. Okay, for whom is it clear? For whom is it not clear? It's clear. The fourth one, avoid aggregating grouping columns. Well, again, that's common sense. That's what I told you earlier. You see that here I put, whenever we have a group by, we have a very strict separation in here. There is a wall. We have the grouping keys on the left. We have the aggregation on the right. Do not mix them up. Always strictly separate. So century, you either group or you aggregate. So century, you group, it's on the left. Captain, you aggregate, it's on the right. Do not use a colon here and also here, right? Avoid doing that. You really need to make up your mind for every column. Either it's grouping, or it's aggregated, or you don't use it. But do not use a colon at multiple places. It is, again, going to be confusing. So it's a good thing to stick to that. And do not use having alone. I think you wouldn't get an error if you actually use having. It probably will not complain, but that doesn't really make sense, right? It's a little bit like limit and offset without order by, except for the purpose of not exploding your Jupyter notebook, as I said. But having, typically, if you have having, it should be with a group by. That's really what it was, it was designed for. Okay, so these are the best practice advice, pieces of advice that I'm giving to you. Okay. Do we want to go over all the clauses we know now? What I haven't told you yet is the order between group by and order by. Do you think group by is before or after order by? So order by is after the group by. So technically, I'll tell it to you and then we do it together. It's select from, where, group by, having, order by, limit, offset. Always in that order. Do we do it together? Okay, everybody, 3, 2, 1, select from, where, group by, having, order by, limit, offset. That you can learn by heart. They're optional, except select and from, but it has to be in this order. Okay. I still have 4 minutes to the break, so I'll do a quick reminder of the joins, because now I'll show you how to do joins in SQL. We just keep getting into more and more complex things. So joining, you remember it's this weird symbol here that looks like a multiplication, like a cross, but with the additional 2 vertical bars in here. So this is the join. More exactly, this one is a natural join because it doesn't have any subscripts. Remember the subscript if you manually specify the predicate, but here there's no predicate. What happens if there's no predicate? What do we join on? Exactly, we join on the columns that are the same. So in that case, because we don't specify anything in here in a subscript, it means that we are joining on the columns that have the same name. So B and B. If everything's going okay, you should really check they have the same domain too, because otherwise that's kind of broken. So you really have to check when you do a natural join that they match. All right. So now you see if we do the join, this one is going to be matched with this one, and this 2 is going to be matched with this 2. And the 3 here is on its own. So it's not associated with anything. So this is just not considered. So these are the 2 survivors. We have here foo1 true that comes from the left, and foo1 comes from here. Then we have bar2 false, and then the d equals bar comes from here. So it's the joint table. That we saw, right, 2 weeks ago. That's a natural join. Now, if you do add a subscript, then you specify what matches what. And here, you don't need to care about the matching columns or not matching columns. We just say A equals D. It means we match this column here with that column here. So the foo here will go with this one and this one. And the bar here will go with this one. That gives us 3 matches that we have here. Is everybody with me? Okay. This is called, what is the Greek letter that we call it? Yes? A theta join, exactly. That is a theta join. For a reason I don't know, we don't use the actual theta letter in the formula, but it's called the theta join. Okay. I should let you go to the break before I show you the SQL, but at least now it's fresh on the top of your mind. So I'll see you in 15 minutes. So we continue at 15 past 11, right?